All right, today we're going to do a quick repair. This is going to be a short video, and it's just the classic iPhone 6 backlight fault. So I've seen a lot of misinformation about this on some forums, and I realized that we've done this a few streams, a few videos. They're all pretty long, they're pretty buried. So this one came up today, and I'm just going to do this very quickly the way that I address iPhone 6 backlight faults in the most efficient, fast way possible. So let's get started. This one here is a classic presentation of the iPhone 6 backlight fault. The primary problem on these is a short to ground. So a short to ground or a partial short to ground. So let's start by seeing what we mean about short to ground and what we're talking about. The short occurs on the backlight caps. So this, I'm going to switch in a known good board. So this is a donor board. And I'm going to show you here on the multimeter what the normal diode mode reading should be. So to get a diode mode reading, I'm going to put red probe on ground. So I've got my red probe on ground there, and then I'm going to find one of these three backlight caps, and they are in this area of the phone. There's two VCC main caps, and then the backlight caps are 1, 2, and 3. So any of those we can pick and take a diode mode reading. And the diode mode reading is 0.5 something. So 0.5 is normal. You could similarly, without having to take off the shield, you could take that diode mode reading out here at the backlight filter or even at the connector, and you'll get that same value, which is going to be 0.5. 0.5 is normal. So we could take the reading out here without actually having to desolder the CPU shield. So on the device we're trying to fix, this is a phone here with no backlight, classic failure. All right, so let's take a diode mode reading on our dead board, on our no backlight board, and see what the result is here. All right, so we'll similarly find those same three caps. So not this one, these two are VCC main, so this one here with a solder ball or any of these three. And I'm getting 0.01. So that's definitely a short to ground. That's the primary fault. So before you do anything else with an iPhone 6 backlight, you want to check to see if you have this signature failure, which is a short. And the short is going to be on one of these three caps. Any of the three can fail. So then you're going to say which one is likely the one that's turned into a wire and is causing the short to ground. So we can kind of take a guess and say, well, it's one of these three. Let's try to get lucky and pick the bad guy on the first try. So of these three, 1, 2, 3, you can look for some kind of discoloration or some kind of a tell. It's pretty obvious that one of them has shit out a solder ball. So we're going to go with, hey, we're going to put our finger on this guy and say, hey, you're probably the bad guy. So I am going to just use an X-Acto knife. And you can see when they're damaged, they're really not even attached to the board very well anymore. So just with an X-Acto knife, I can get this dude off. All right, so he's off now. Let's get him. Wow, look, that solder ball's stuck under there. And now that he's off, we can actually use the multimeter to ask, was that capacitor a wire? So a capacitor is not supposed to have continuity across it. So let's see, and I'm measuring him just wherever he fell. Here, right here, buddy. That guy is a wire. So that was probably the primary reason why our backlight failed. All right, so let's go back now and say, did we at least correct that short to ground? And I'm going to kick out that remaining solder ball that's down there at the bottom. So let's just get rid of that. Kick that out. Let's get it like totally off the board. All right, fine. Now let's go back and do that same diode mode reading again and see what it is now that that cap is gone. All right, so now our diode mode reading is, I don't know, I can't really see it. Can you? It's probably 0.5 or 6. I can't really see that. So we're going to say that that looks like it is 0.6, great. So now it is back to within the normal range. 0.5, 0.6, close enough. So what are the consequences then of the fact that that cap's short? Are we done? Can we just light this thing up and go? And the answer is no, because when the cap becomes a wire, that creates a big kind of multi-car pileup of giant accident on the entire backlight circuit. So if we could spend a lot of time trying to figure out whether or not each individual piece of the backlight circuit was actually affected and whether or not it needs to be replaced. But they're all in the same area. So this here is the backlight diode. And the backlight diode, you can see it's burnt. See how it is just kind of really fried looking? It's brown, it's discolored. We could measure that to see whether or not it's failed, but it's all encased in underfill. It would be kind of difficult to take a measurement there. The backlight driver chip is probably okay, but it may have had some damage, especially if we put heat on this area to attempt to change the diode. Then we're going to cause damage to the backlight driver chip because it's underfilled and it's like it's in a straitjacket, so it can't really withstand any kind of heat. And then the coil. So the coil here, we can see this classic thing, this little bit of green goo coming out of the top of it. We can see that it's cracked along here. Now normally a coil doesn't really care if the housing around it is cracked. So after drop, it's pretty common to see coils with cracked housings. They don't really care about that. They can dilute, you can take a hammer to their housing and they'll be fine. But they do need to have two things in order to function. One, inside this thing, the coil is just a slinky, a coil of wire. It has to have, number one, both ends of the wire have to be soldered onto the pads below. So that's rule number one. And number two, the coil has an inherent property of inductance, which is going to be the number of turns in that slinky, the number of turns of coil wire. The coil wire is separated from itself because the whole thing is insulated. And what we find in this particular problem, that layer of insulation will heat up, burn off, and that's what seems like it's coming out the top. And therefore, the coil kind of becomes fused together. So while it still functions, and if you did not replace the coil, you would get a backlight, it just may not come to full brightness. So we don't know whether or not this particular coil is okay or not, but since it's in the same area with the diode, that's definitely bad, and the backlight driver chip, it's going to be the easiest way to solve this by just saying, let's windshield wiper this entire circuit and just replace everything all at once, and that'll be our most efficient path to success. No measuring voltages and wondering and stuff like that. So let's go ahead and do that. Let me grab my my board holder. And the question on the stream is, are you ever worried about tearing the pads off of these capacitors? And I think that that is something that comes with experience. If you have worked on an area before, you kind of get to know the components and how they behave. And these particular caps, no, I've never torn a pad, and I don't worry about tearing the pads like that. Same for C5202 and the common cap that's bad in iPhone 6 water damage causing a VCC main short. That cap you can just knock off. It will never tear a pad. That'll be totally fine. All right, so for us, let's kind of orient this around a little bit. Now I'm going to be putting heat on this area in order to, all at once, I'm going to get rid of the driver, the coil, and the diode and windshield wiper this entire circuit and replace all of that as the sort of easy way to fix iPhone 6 backlight problems. All right, so I'm going to be putting heat on a chip that is near an underfilled chip, the CPU itself. So I have to protect that CPU, so I'm going to protect it, not with Captain tape, which is just a piece of tape. I'm going to protect it with a piece of metal, something that will itself heat up and so kind of draw some of the heat, keeping it off of the CPU below. Just enough so that I can get in there, get what I need to do done, and get out before the CPU itself has a chance to really heat up those solder balls. All right, so let's go ahead, and first we're going to try to get this silicone waterproofing out of the area. And we're going to need to dig up the actual underfill. And there seems to be a lot of it on this particular one. So we need to get this underfill out of the way. That way we can take these components off without them kind of bringing the whole family along with every other thing in the area. The underfill acts like a glue a little bit, and if we don't remove the underfill, when we take these components off, they will kind of carry with them their neighbors, and we really don't want to do that. So I'm heating up what has really been a cold board. I'm just starting work on it right now. So with heat, the underfill is pretty easy to work with. It's not a big deal to just come in here and remove this whole area. Alright, so there's my diode. There's my chip. And I'm going to switch to some heavier dutier tweezers. Heavier dutier. That's probably not really a word. Knock that off. Now here's something that's a common problem that you could have. So in nudging that, you can see I've nudged these two caps up. That's not a big deal to put them back. But you can also see here that I have nudged these resistors. Now resistors are important, and those will definitely need to go back into their spot in order for us to have a successful repair. Alright, phase 2, we're going to clean up this area. So while the board is still warm, I'm going to get rid of the remaining underfill so that I can have a nice, clean, clear surface to work with. Alright, and then I see a question in the chat of, do I need to worry about putting the cap back? From a practical perspective, you can get away with not putting back one. So let's say that I was wrong and I picked the wrong cap to take off, so I took off a good one, and then I had to go back and find the actual bad cap. In that scenario, I'd have to come put back some caps. I'm going to put back the cap just sort of for good practice, and because this is such a common fault, we stock a strip of those caps, so it's no big deal to put the cap back since we're already working in this area. Alright, now I want to be careful when I'm doing this. I'm picking underfill out from between BGA balls, and I will really do myself a favor if I first mash down the balls with a soldering iron. Because right now they are kind of like hot air balloons on a stem, so it's pretty easy for me to dislodge one of these guys and actually break it off, which would probably break off the pad itself. So I'll make it easier on myself if I just come in here and get rid of the solder balls that are left there. So let's put some flux down and mash down those balls. Alright, so let's do this. So I'm going to grab my mini hot tweezers. And all the tools that we use are linked below in the video description, always, on all of the videos. I do like the live stream format because I don't have time or the patience to edit video. And that's extremely laborious around here. To render a video takes like a whole day. To upload a video takes a whole day. And by then, you just kind of don't really care about that particular repair anymore. So I really like the live stream format. But I've noticed that you know, a lot of the streams kind of end up being kind of just a big party. And I recognize that it can be hard to kind of, you know, get the information that you really want. So I'm going to try to, every now and then, if I have a straightforward repair, to do a short stream like this one, so that this will ultimately turn into a video without me having to edit and without me having to spend a day of my life uploading video. All right, let's clean this area off a little bit. Has been a good day to watch some streams. Oh, that's great. All right. So I'm going to get this off, and I'm going to be careful not to lose my little resistors that I need to put back over there. All right, so I need to do a little bit more work on cleanup before I'm ready to put my new chip down. So I'm going to go ahead and get rid of all of this remaining silicone waterproofing and underfill. It's really important to have this be very clean because my new chips that I'm going to be putting on need to have room to dance. They got to find their own way. They got to find their own exact spot on the board by surface tension, and I don't want to have like a speed bump of underfill that would prevent them from getting to their spot. All right, now this little bit of the housing that is under here is a little less important to remove, so we'll just kind of take a stab at getting that off. Have you always had the Fluke 115? Yes, I've always had the Fluke 115. For the course, I guess we bought the Fluke something else, 110 or something, 105, whatever it is. But the Fluke 115 is I like because it will give you a little beep on diode mode. So I can tell on diode mode when I'm actually touching the components. Now I want to be really careful here when I'm messing around at the coil. I don't want to dig up ground plane because that would be a problem. If I scratch too deeply right here, then I'm going to end up exposing that, I'll rip off the conformal coating and I'll end up exposing ground, and then it will really complicate the repair because that coil obviously can't touch ground. Coils and filters have no path to ground. All right, so I'm good with that. So this looks pretty cleaned up to me. Let's get some alcohol. And then we will start to rebuild. So let's get that just alcohol cleaned up. All right, that looks good to me. Now the first thing I need to do is correct this little mistake that I made nudging up these two caps and these two resistors. So I want them to go back home. I'd rather not lose my two resistors there because then I'd have to go get some new ones. So we'll see. I don't know whether or not I'll be able to actually preserve them or not. All right, so I'm going to start by getting a little bit of flux there because I'm going to put back a new cap, and you can see the pads are not puffy pillows. I can't solder on anything that's not a puffy pillow. So there is still the remnants of the old component stuck on there a little bit. So I need to get that off. So there's one coming off. And we'll get the other one off. All right, so now I've got two puffy pillows ready for the new cap. So I think I'll do this in 2 stages because I have to correct that other damage. And I will grab a new cap. So this is a brand new cap from a strip that I stock. These are all 2.2 microfarad caps that match the schematic. So you can look up capacitor C1531 or his two brothers and see that for yourself on the schematic, and then order caps to match. You can order them from lots of places like Jason at microsolderingsupply.com. Ultimately, we'll stock a little kit for this job. Backlight, iPhone 6 backlight, iPhone 6s backlight on the iPad rehab supply store, but right now that isn't something that I've gotten around to doing. All right, so let's just do a little skills workshop here and see how can we do with just some hot air and a little maneuvering. So let's see what we can do with some flux and some hot air and just kind of asking these guys to behave. So let's see. Can these guys be cool or not? Alright, come on, bro. Go back home. Mom's calling. It's dinner time. Okay, I'm pretty happy with that. Now I want to nudge these resistors and just make sure that they are actually soldered on and not just loose. Seems to be okay. And at the end, before I put power through this, I'm going to come back with my multimeter and just test to make sure everything is fine. Alright, so let's go ahead with the diode, coil, and driver chip. So we're really windshield wipering this entire circuit, which I think is the fastest way to just get these suckers in the done path. Alright, so let's grab a diode. Now the diode, we have to be real sure that we get it in the right orientation, because diodes are one-way valves. They let current flow in one direction and not the other. So we have to make sure that we put the diode in the same orientation as the one that we took off. So for the iPhone 6 backlight diode, it has a little stripe on it that you can see. See the little white stripe on the left? And that white stripe goes to the left, pointing at the, kind of pointing out to the LCD connector. So the diode is going to go there, and that's going to be a little loose and wiggly, but we'll try to deal with that as we put this stuff on. And now I'm going to grab a driver. Now the driver is a chip, and for any BGA chip, it also, of course, has an orientation. You have to put it on in the right orientation. Now the old driver probably doesn't have anything wrong with it functionally, internally. So we could reball it. But for the sake of keeping things simple and fast and efficient, we're going to just use a new one. And then we might hang on to that old one and reball it later when we have a big old reballing day. A good old-fashioned reball. Alright, so the dot on the iPhone 6 goes up here to the right on the backlight driver. And if you forget, you can look it up in the schematic and you'll see a little red dash. If you're using ZXW tool, you'll be able to see a dot or A1 pad. Alright, so this has more flux than I'd like it to have in this area, so we'll try to kind of live with that. And just see if we kind of come in slow, if the flux will just sort of run away and thicken up. So we'll come in sort of from farther away than we otherwise would. Reball now. Nope. Not gonna do it. I did a bunch of reballing in NANDs earlier tonight, and I've put away and retired all the reballing stuff for today. So what I really care about is the chip. Chip needs to dance, chip needs to move, chip needs to find its own spot. Alright, so diode is good. See the chip moving? There he goes. Good job, buddy. Yeah, get your spot. You got it. I really want him to find his own spot. Alright, so that is chip and diode. And last, we're going to put on a coil. Now here's a trick that I've been doing ever since we started seeing these like a year ago. I did remove the coin. Someone in chat is asking about removing the coin. As soon as I take the heat away, I knock the coin off. I want to take that heat away, so I push the coin off as soon as I'm done with the hot air, and then when I bring hot air back, I put a new coin on that's cool. So I have a little bin here of different coins that, you know, come on and off the board all the time. All right, so here's the trick that I've been doing since I started doing these when we first discovered this problem. So this problem trolled us for a while because we didn't, we knew strongly from all other versions of iPhone since the 3G that a slinky, a coil, really doesn't have a way to fail other than coming up off the pads, and that doesn't happen. So this style of coil is the first one that has had this ability to get hot and exude its insulation. All of the other coils have more of an open design where they just don't do that. So there's really no, you'll never see an iPhone 5 coil lose its inductance. So what we do, that since the inductance is the same in the style of the iPhone 5, 5S, 5C coil, the inductance is the same. So functionally it's the same, it's just a different style. I prefer the iPhone 5 style coil. So I am going to install, instead of the iPhone 6 coil, I'm going to install an iPhone 5 style coil, and we can see what that looks like. And the reason I like to do that is just because it fits on here with an iron, so I can use an iron to install the coil. It's also magnetic, and it sticks to my blue magnetic tweezers. Here's my two favorite tweezers, greenies and blues, and the blue are magnetic, but the green are really, really weak. You can look at the tips. The green tips are all jacked, and the blue tips are nice, so it's kind of a trade-off. I love them both. All right, let's go ahead and turn this so that we can solder this on very quickly with an iron. And what I found early on is if you try to harvest coils from one 6 to another, then that is going to, you know, just the action of trying to get one of these big coils off of their pads intact and have it function and not be all mashed up, that's really tough. And so going with the iPhone 5 coils as a substitute really, really simplifies this repair. All right, plus that's how we discovered this way back when. It was Mark who found out at some sort of 3 or 4 o'clock in the morning. We had tried replacing iPhone 6 coil with another iPhone 6 coil, and we got trolled by that very thing, which is it's very difficult to harvest one from one board and put it on another. So we did that once or twice, and we had kind of ruled out that the coil was the problem when these phones would come back after, you know, after you replace the chip and the diode and everything no longer had a short, they would have this odd presentation that they would only go to like maybe 30% backlight. They would slide the slider, but they would not increase in brightness after 30%. And that really kind of seems like a coil problem, so we'd replace the coil, but that didn't solve it. So we were trolled by that for a while, and then it was Mark Schaefer, so credit for Mark, who said, guess what, one night at 3 or 4 o'clock in the morning. And he said, I took an iPhone 5C coil just out of desperation and switched it in on one of these 20 or 30% iPhone 6 backlight problems after solving the short, after replacing the diode, after replacing the chip, and it solved it. It came to full brightness. And that's how we discovered that the iPhone 6 classic signature fault is short to ground, which takes out diode always, sometimes chip, and sometimes also lowers the inductance of the coil. And so it's kind of a full Monty kind of repair here. All right, so there we go. Let's look at that now and see if we're ready to test. All right, so we've got our new coil, so we can get out our multimeter and just before we put power through a device, just say, hey, she said my name. Say my name. Yes, the amazing Mark Schaefer. So let's go ahead and see what happens. So we'll wake this sucker back up, and first let's just see, do we have continuity across the coil itself? Because remember, coils can really only stop you in 2 ways. Why is this multimeter? Are you asleep? What's your problem? You are on diode mode. You should be ready to go. All right, so let's just see. Do you, Coil, have a foot on each pad? And we get a beep across, so yes, he does. Now let's ask him, are you short to ground? So I'm going to put one probe on ground, so I'm on ground up there, and I'm going to touch it. No, he's not short to ground. Excellent, that is great news. Now let's ask if we have, since I kind of moved these guys around a little bit, let's just go back and say, what is our diode mode resistance on any one of these three caps? So we can just pick the one that we just put, and hopefully, let's wake this up on the light again so that I can see it since I'm looking far away. And it is 0.467. That's close enough. We'll call that good to go. All right, too much responsibility. Why isn't Mark Schaefer a mod on his own workplace channel? Oh, yeah, Mark should probably be a mod. Because Mark doesn't watch the iPad Rehab channel, ever. In fact, this is the first time I've ever seen Mark watching the iPad Rehab channel. So things must be really fucking boring in New York. All right, so we're just kind of probing around to make sure that we have a line of continuity from inside the connector. And this is something I saw on one of these forums where it was just a mad house of trolls and please bros, which was, you know, failing to recognize that you can measure a filter. You can measure it like this across the filter and get a beep. But it's easier to measure it from inside the connector, and better, because then you're really testing whether or not the filter made a joint. So we can measure from inside the connector all the way out here to the backlight circuit, and all of that seems okay. So the only real variable is, did the little resistors really make nice joints where they're supposed to? If they did, this phone will probably work, and if they didn't, then we would come back, and that's where we would look first. All right, let's go ahead and test. Let's stick this guy with a screen, and I've been using my my Fine Fix board holder. I love these. So we did stock these on the iPad Rehab Supply Store because they are one of those things that we really recommend. So let's stick a screen, and for these you have to not just say, hey, I've got a light. You have to test to see, do you have a full display? Do you have a light on the entire screen, because it's possible to have a separate failure of a cathode line. For example, if you actually look at what the chip does, the chip has to send out the anode voltage, but it has to also get back that cathode voltage. If you have a cold joint under that chip, it could show up as a half-dim screen. So that's one potential fault we'll be on the lookout for. And the other is full brightness. Does that coil really have the inductance that it needs to bring that screen up to full brightness when you are, you know, in the bright sunny day and you really need to get that phone super bright? You want to be sure that the coil can do that. All right, let's test and see if this is going to work. All right, so I will show this to you guys. So I've just plugged in a battery and a screen, and I have an Apple logo. So let's go ahead and go back to our regular image here. All right, well, we're gonna see if they sent us the passcode so that we can actually test this thing. They did. All right, so now let's see if this phone will actually boot or not. And then we'll see if it comes to full brightness. All right, she only streams at 4 a.m. I like to sleep sometimes. Mark is always up at 4 a.m. That is a total lie. All right, let's check passcode. All right, so we have a display, and let's go ahead and go to settings and display brightness. And this is what we want to see. It's kind of hard. I'm not sure how to get the camera to really pick this up, but I want to be able to go from dim to full brightness, and that is full brightness. I have full control all along the length of the slider. It doesn't just kind of get halfway or 30% and then not go anymore. That would be a symptom of bad coil. So there we go. We have fixed iPhone 6 backlight with the windshield wiper method, and I really highly recommend that. I see on forums a lot of people struggling. I've found the cap, or I've seen professionals even that will just replace the coil, because now everybody knows iPhone 6 backlight coil, so they'll just replace the coil, or they'll just replace the diode. And you really solve these best, in my opinion, by just windshield wipering the entire circuit. So that way you're avoiding leaving a component that may have been insulted by that original short. It's a very strong insult to suddenly take the backlight voltage, 20 volts, and short it into the ground of the board. That's a lot of energy. And that causes a lot of heat damage. Just components don't like that. So if you just at one time replace the backlight cap that's bad, and you figure out which one's the bad, that's the primary problem. Replace the cap, replace the chip, replace the diode, replace the coil, then you've really knocked out the entire circuit. Filter is going to be fine because the failure occurs internal to the filter in the iPhone 6. And that is iPhone 6 backlight. So that's it for our content here. I'll answer a few questions on the stream, and then we're going to be done. So I haven't looked at the stream, so let's see if there's anything that is relevant to this particular phone. So let's go back to the beginning of this stream. All right, I see some hellos. Takes forever to convert videos. Fluke 115. And I do not wick any kind of, no need to wick. That's a big danger. Don't want to do that. All right. The other flukes will too. You just got to hit the right mode key. Really? What flukes are those? I think they're 110 maybe. I'm not sure. Drop-in screen repair at Apple Store in Norway. All right, that's expensive. Save the resistors, delicate work, so steady. Clearly doesn't spend all day drinking and watching right-wing YouTube streams. Can't imagine what you're talking about there. All right, the dot denotes pin 1. Yes, A1. Yes. Did you remove the coin? We talked about that. I wonder how many times a chip can be heated to reflow before they fail. Probably, a lot. I mean, that's how they get on the board to begin with. So they are rated, and you can look this stuff up, that they'll withstand X seconds at X temperature and things like that. All right, iPhone 5, they are typically wave soldered. Yes, they have to be able to take a bit generally. Oh my God, that's totally what I just said. Although some iPhone chips can be real wimps. Yes, that's pretty funny. All right, let's see, that's good information. Popping in during the Hulu ad breaks. Ha ha ha. Mark, I believe, is in New York City, hopefully. All right, you're never in just live streams no more. Is he skipped town? All right. I think we're close to the end here. I do the windshield wiping method too. Yes. People are talking about other phones. And so talking about NAND reball. So that is it for iPhone 6. There's one thing that I want to say. So if you stuck in to watch this all the way to the end, one of the things that people miss about this is they will just check for a short using continuity mode. So if you put your multimeter in continuity mode, so that's beep mode, so that you get you get a beep when you put the probes together. So if you're just using continuity mode, then you're using that to say, hey, is there a short? Does it beep to ground? That's the multimeter is going to beep if you have something like, I don't know how many ohms, 100 or something like that to ground or less. And if so, it will beep. However, you can totally have, and this happens all the time, a partial short on these exact backlight caps. Sometimes you'll even have people that, I'm pretty sure my own phone is doing this, where people will say, you know, backlight kind of goes out and then it'll come back, and that happens a little bit before it totally dies. So it sounds like these caps kind of fail in a way that they don't become full short wires to ground. The way to find it is to use diode mode instead of continuity mode. So diode mode is like your quantitative method of short detection. Continuity mode is your qualitative method of short detection. So get away from the beep testing. If you know what that known good value is, which we just decided was 0.5, something close to that, then red probe on ground in diode mode, and then you touch anywhere on the line, in the connector, at the filter, at the caps, anywhere on the line, it's all the same, and you measure that line's resistance to ground. If it's something less than 0.5, if it comes up as 0.2, then that's a problem, and you need to figure out which cap is bringing that resistance on that line down, and it will be this exact same problem. So there's your last tip, and that is really all that I have to say on iPhone 6 backlight problems. So with that, we are done, and best of luck fixing those things.